All right, if we're looking to evaluate this expression log base 8 of 128, there are a couple different ways of attacking this, but what I would do is rewrite this in exponential form. Just a real quick review of that is that if we have the log base b of x equals y, that's exactly the same thing as b to the y equals x. Logarithms are simply the inverse of exponential expressions. So again, this b is the same as that b. The exponent of y is the output of the logarithm. And then the input for the logarithm is the result of this exponential expression. So in order to do that, I'll just use a variable. Let's just use x in this case to set the log equal to it. And then what we rewrite this, an exponential expression would be 8x equals 128. It would be really nice if 8 to some nice power was 128, like some whole number, or just at least an integer, but that's not the case. But we can use the common or like base property. So we need to find a number, in this case it would be 2, that I can raise to an exponent to get to both of the current bases that I have. So 2 to the third equals 8, and 2 to the 7 equals 128. Then what I'm going to do is I'm going to replace the 8 and the 128 in this expression with the 2 to the third and 2 to the 7th. So 8 is 2 to the third, and we got 2 to the 7th for 128. This 8 over here was being raised to the x power, and there's nothing going on to the 128. Next thing I'm going to do is just clean up the left-hand side of this equation using some property of exponents. If I have an exponential expression that I'm raising to another exponent, I would multiply these exponents together, so I will do that now. I have 2 to the 3x over there, and 2 to the 7th. And we're basically done. The common base property says if you have an equation, two exponential expressions are being set equal to each other, you can solve it by simply setting the exponents equal to each other. So we take this and we're going to rewrite this as 3x equals 7. Finally divide both sides by 3 to get x equals 7/3. Again, x represented this original logarithm up here at top. And so we've solved, or we've evaluated our logarithm, and we got 7/3.